Switches. In learning outcome, we have two types, and the first one is discuss how to design and configure switches. Switches. A network switches connect devices such as computers, printers, and wireless access points in a network to each other and allow them to talk by exchanging data packets. Switches can be hardware devices that manage physical network as well as software-based virtual devices. Design switches. In its local connection and in its connection to wider network, including the internet, a major problem in the past has been security and contention on Ethernet network. Switching overcome both these problems as it can create VLANs, virtual LANs, which allow nodes to be isolated from each other. Eventually, they connect to the same devices. Switches avoid the problem of connection on a network as they take frames from one interface and forward it to another. This can take place at either layer 2, data link layer, or layer 3, network layer. Routers implement layer 3 switching to router data packets and switches. Layer 2 switches use layer 2 switching to forward frames. In layer 3, switching, the router examines the network address and decides on whether it should forward it to another port. Whereas with layer 2 in the switch examines the MAC address of the data frame. It thus ignores any network layer information. A layer 2 switch must build and maintain a switching table that keeps track of the MAC address that belong to each port or interface. A switch, the ARP protocol. The layer 2 switches send out a broadcast on all of its ports if it does not know where to send a data frame. When the address node detects its address, it sends back an ARP reply and the switch adds the new address to its switching table. The MAC address itself is a 48-bit address made up of the manufacturing or MFG code and the unique identifier. Organizations have no control over the MAC address, and they have a flat addressing structure, whereas layer 3 address are typically organized in a hierarchical way, typically using IP or IPX or AppleTalk addresses. For the access layer, design considerations include the following: the number of end-user devices to be supported, the applications that are being used. This defines some of the features required in the switches, as well as the performance and bandwidth needed. The use of VLANs, including whether trunks are required between switches, and redundancy requirements. For the distribution layer, design factors include the following: the number of access switches to be upgraded, features required for a specific application to be supported, and required interface to the core layer. Scalable switching. Deploy switching at all levels of the network without the use of router. In this design, each layer consists of switches, with switches in the access layer providing 10 Mbps Ethernet or 16 Mbps token ring to end users. Scaled switching is a low-cost and easy-to-install solution for a small campus network. It does not require knowledge of address structure. It's easy to manage and allow all users to communicate with one another. However, this network comprises a single broadcast domain. If a scaled switch network needs to grow, beyond the broadcast domain. It can use VLANs to create multiple broadcast domains. Note that when VLANs are used, end user is one VLAN cannot communicate with end user in another VLAN unless routers are deployed. Large switch, minimal routing. The large switch, minimal routing design deploys switching at the access layer of the network, either ATM switching or LAN switching at the distribution layer of the network, and ATM or LAN switching at the core. In the case of ATM, in the distribution layer, the following key issues are relevant. Lane support on routers and switches. Support for UNI 3.x signaling, including point to multipoint. If redundancy is provided by a virtual PVC or SVC mesh, the mesh is a single point of failure. In the case of LAN switching in the distribution layer, the following key issues are relevant. Support for VLAN tracking technology in each devices. The switches in the distribution layer must run the spanning tree protocol to prevent loops, which means that some connection will be blocked and load balancing cannot occur. To scale the large switches, minimal routing design. A logical hierarchy must be imposed. The logical hierarchy consists of VLANs and routers that enable inter-VLAN communication. In this topology, routing is used only in the distribution layer, and the access layer depends on bandwidth through the distribution layer to gain access to high-speed switching functionality in the core layer. The large switch minimal routing design scales well when VLANs are designed so that the majority of resources are available in the VLAN. Therefore, if this topology can design so that 80% of traffic is in intra-VLAN, routing is not a concern. However, if inter-VLAN traffic is greater than 20%, access to routing in the core becomes a scalability issue. For optimal network operation, scalable routing content is needed at the distribution layer of the network. Distributed routing switching. The distributed routing switching design deploys switching in the access layer, routing in the distribution layer, and some form of high-speed switching in the core layer. The distributed routing switches design follows the classic hierarchical network model both physically and logically because it provides high bandwidth for access to routing functionality. This design scales very well. This design is optimized for networks that do not have the 80 to 20 pattern rule. Its servers are centralized most traffic in inter-VLAN. Therefore, high routing content is needed. And the number 2 is the different network and port security rules. Number 1. Personal Area Network or PAN handles data transmission within devices such as tablets, personal digital assistants, smartphones, and computers. Note that single user is most cases basically use this type of a network. People make use of these types of networks commonly in situations where they need to connect wearable or mobile devices. And local area network. LAN, as it's commonly known, is a network that connects devices usually in the same building or local area. This could be computers or other devices that are within an office building, which are connected together to share share resources. Most people make use this network type to share files and other businesses related documents in an organization. Metropolitan Area Network or MAN. When it comes to the MAN network type, known that it is usually a large computer network on a large geographical area that includes several buildings and lands or even the entire city or metropolitan area. The geographical area of the MAN is a larger than land but smaller than one, which makes it fall in between a local area network and a wide area network. Wide area network or WAN. Network that is span over wide geographical location, which could be multiple buildings or even multiple cities or countries. This kind of network is suitable for providing internet access to local area network or some other kinds of networks. And the wireless LAN or WLAN. Wireless LAN network doesn't make use of a cable for end-to-end connectivity. WLAN make use of a wireless access point or WAP device, which serves as the point of connectivity for wireless client on the network. Keep in mind that this kind of network can support other devices such as smartphones and tablets. One of the advantages of using a WLAN network is the flexibility it offers users since there is a cable restriction. Virtual Private Network or VPN can provide a secured network connection, and it is also used to connect LAN networks that are far away between them. For example, a company has different buildings with LAN networks in different cities and want to interconnect the buildings or the internet. A VPN will provide an ideal and cheap solution for such a case. Storage Area Network or SAN is a network that has been designed for storing and transferring files. This network setup is often made up of servers with large storage capacity and special switches and interface cards. And enterprises internal private network. An enterprise internal private network is a type of network that is designed for private communication within an organization. This type of a network is only accessible from within the enterprise since its major goal is to provide security for users within the organization. A firewall is often used when users needed to access information on the internet. Campus Area Network, basically made up of several local area networks, which are often within a campus area. Campus area networks are used in places such as hospitals, schools, universities, or any organization that has multiple LANs and including that need to connect to each other to share resources. And a system area network is a network that is designed to work in parallel computing environments. It connects computers that are in high performance computing setting. These are often used where high processing is needed. Computer clusters make use of system area network to achieve connectivity. The major difference here is the distance in between the computers on the network, which is often a short distance.